right, so just remember, we are finishing off with triangles. So just in case you recap the triangle theorems that we've learned is that triangles, one, that we know all the angles sum to 180 degrees. So 180 degrees, that's the first thing. Two, we know that the two smallest sides of a triangle have to add up to more than the third side. So for example, we know that if you have sides of 4, 5, and 7, you would test the two smaller sides, 4 and 5, so 4 plus 5, and check if it's greater than 7. If it is, then yes, it's a triangle. Or another example is if you have 3, 8, and 5, the two smaller sides are 3 and 5, so you check 3 and 5. 3 plus 5 is equal to 8, so this is not a triangle. This would just lay flat. And the other situation is where you have, let's say, 1, 5, and 3. The two smaller sides are 1 and 3. 1 plus 3 is not greater than 5. So therefore, this is not a triangle. It won't even lay flat. It wouldn't connect. So that was the things that we talked about in regards to triangles. All right. We talked about how triangles have a first and a last name. The 7 different triangles we have is acute isosceles triangle, and that just means you have all 3 angles are less than 90 degrees, and 2 of those angles are the same because 2 of the sides are the same. You also have acute scalene, and that's just that all 3 angles are less than 90 degrees and all of them are different. Now, the reason why the angles are all different is because the sides are all different. You also have the Cher, the Beyonce of all triangles, the acute equilateral, the only equilateral triangle there is. All 3 angles are less than 90 degrees and all of them are the same, which means all of them are 60. That's the only number. Then you have the right isosceles. That means you have a one right angle, only right angle, and the other 2 angles, acute angles, are congruent. Because if you have 2 congruent sides, they have 2 congruent angles. You also have the right scalene. And the right scalene means you have one right angle and all of them are different. The reason why they're all different is because all the sides are different. You would think you have a right equilateral, but you don't, because this implies that you have one right angle and all of them are the same. That's impossible. You can't have 3 right angles in a triangle, so that one is impossible. Then we go to the obtuse. You have the obtuse isosceles. And for the obtuse isosceles, you have one obtuse angle and the other 2 angles are congruent because the other 2 sides are congruent. You have the obtuse scalene. Obtuse scalene, you have one obtuse angle, but all 3 angles are different. And then you also have or you think you would have the obtuse equilateral. Now, you can't have the obtuse equilateral because you'll believe that you have one obtuse angle and they're all the same. That's impossible because you can't have 3 obtuse angles. So these are the 3 possible triangles, the 7 possible triangles that you can have, and the 2 that you cannot have, the 2 that are impossible. So that's just a closure on what we did on this page. So now going into the next page, which was quadrilaterals. Remember, quadrilaterals is a 4-sided polygon. 4-sided polygon. And then we're talking about some special quadrilaterals, but keep in mind, these are not the only quadrilaterals. So some special quadrilaterals, the first one we'll talk about is a trapezoid. Now, what's important about a trapezoid? Look at the markings on the diagram. It has 1 pair of parallel sides. Look at this, is not a trapezoid, so it can't have 2 pairs of parallel sides. So our definition for a trapezoid is a quadrilateral with only 1 pair of parallel sides. The word only has to be there. With only 1 pair of parallel sides. Or a kite. Based on these tick marks, we see that it has 2 pairs of congruent sides, but this one also has 2 pairs of congruent sides, but these congruent sides are opposite. So it has to have 2 pairs of adjacent congruent sides. So it's a quadrilateral with 2 pairs of adjacent, or if you want to use the word consecutive, that works also, 2 pairs of adjacent congruent sides. The tick marks means the sides are congruent. Now looking at the parallelogram. The parallelogram has two pairs of parallel lines. It's a quadrilateral, two pairs. This one only has one. This is a trapezoid. So a parallelogram is a quadrilateral with two pairs of parallel sides. It has two pairs. Don't forget that is the symbol for parallel. So it's a quadrilateral with two pairs of parallel sides. Now a rhombus. For a rhombus, we see that it also has two pairs of parallel sides, but these little tick marks show that all the sides are congruent. So it has two pairs of parallel sides and all congruent sides. So basically a rhombus is just a special parallelogram. A rhombus is the parallelogram that has all congruent sides. But for our definition, we're going to write it all out. So it's a quadrilateral with two pairs of parallel sides and all congruent sides. In other words, it's a parallelogram with all congruent sides. A rectangle, as you can see, a rectangle also has two pairs of parallel sides, but as you can see here, it's the angles they marked as congruent and not the sides. So we will call it, a rectangle is a quadrilateral. First, we talk about the parallel sides. A quadrilateral with two pairs of parallel sides and all congruent angles. And angles is in the word rectangle. So angles have erect angles, meaning that they stand at 90 degrees. So all congruent angles. Rectangle is for the angles. But basically, since it's a quadrilateral with two pairs of parallel sides, we can shorten this part of the definition here, and we can just call it a parallelogram with congruent angles. Because not all parallelogram has congruent angles, but when it does, we call it a rectangle. It kind of upgrades to a rectangle. A parallelogram with all congruent angles. And last but not least is a square. As we can see, a square does have parallel sides also. It also has the 90-degree angles, the congruent angles, and it also has the tick marks for the sides. So it is a parallelogram, but we'll say a quadrilateral with all congruent sides and angles and two pairs of parallel sides. But again, since it has two pairs of parallel sides, we can just call it a parallelogram with all congruent sides and angles. But here's the thing, a square has many definitions because we know that a parallelogram with all congruent sides is just a rhombus. We said that already. A parallelogram with all congruent sides, located here, a parallelogram with all congruent sides. So this is a parallelogram with all congruent sides. So technically, this is a rhombus that has congruent angles also. A rhombus with all congruent angles. But this also says a parallelogram with all congruent angles. So we can also call it a rectangle with all congruent sides. So it's the rectangle, because the rectangle already has the angles in it, a rectangle with all congruent sides. And we can actually shorten this even more without saying all congruent sides and all congruent angles. We can actually say equilateral or equiangular. So congruent angles, remember, means equiangular. Congruent sides means equilateral. So we can call it an equilateral and equiangular parallelogram. Because equilateral covers the sides, equiangular covers the angles, and parallelogram covers the parallel sides. But remember, anything that is both equilateral and equiangular, what do we call that? Regular. We can call that a regular parallelogram. So the shortest definition for a square, it's a regular parallelogram. It's the parallelogram that covers the parallel sides that has all congruent sides, equilateral, and all congruent angles. So let's go ahead and compare and contrast. Compare and contrast. All right, so a trapezoid and a parallelogram, if we're comparing and contrast, this one has only one pair of parallel sides. And what makes a parallelogram different than a trapezoid? Two pairs of parallel sides. Now, what they have in common? At least one pair of parallel sides. Do not say that they're a quadrilateral, that's what they have in common, because that's what all these shapes has in common, and that's too general. Between a square and a rhombus, what makes a square different than a rhombus is that a square has all congruent angles. A rhombus doesn't need all congruent angles. But the fact with a square and a rhombus, it has two things in common. The first thing it has in common is that they're both parallelogram because they have parallel sides. And the second thing that they have in common is that they are equilateral, meaning they have all congruent sides as well. If you don't want to say equilateral, feel free to say that they have all congruent sides. Rhombus and a rectangle. Rhombus. Now we know the rectangle has all congruent angles. That means the rhombus is the one with all congruent sides. One of them has sides, one of them has angles. If you can't remember which is which, the rectangle is the one with the angles, leaving the rhombus as the one with the sides. And then what they have in common is that they are both parallelograms. They both have two pairs of parallel sides. If you say two pairs of parallel sides instead of calling them parallelograms, that's fine. Now we look at a parallelogram and a rectangle. This angle part of the rectangle is very important. All congruent angles. And the parallelogram doesn't need congruent angles. It can have it, but when it has it, it becomes a rectangle. Doesn't need congruent angles. And what they both have in common, don't just say that they're parallelograms because that's the word here. You need to say what parallelogram means. Two pairs of parallel sides. So if it's the word parallelogram, you can't just say parallelogram here because that doesn't tell the person or me that you know what you're talking about. So in this case, because one of the words you were trying to define was parallelogram, you have to say two pairs of parallel sides. All the other ones, because parallelogram was not the word, that's why it was allowed here, but these two mean the same thing. But if what you're trying to compare is a parallelogram, you need to say that it has two pairs of parallel sides. So that's the compare and contrast for this.